Hello all, welcome to today's GATE video coaching class. Myself Indra, Assistant Professor, Department of Computer Science and Engineering from S.A.ENGG.COLLEGE. Today's topic I'm going to cover is on graph traversal from data structure. The topics to be covered today is data structure, classification of data structure, graph, BFS and DFS. Let us see the first topic, an overview of data structure. What is in data? A data is nothing but, let us consider an example, a mobile which consists of a password. So that is one kind of an information. And next is a structure. Structure is nothing but we are going to arrange in a format so that it can be very easily accessible. So a data structure is a way to store, organize and manage the data so that the operations can be performed like accessing. You can access it whenever you need, and if you want to insert a data, you can insert it, and you can also perform the delete operation, and the information whichever you want you can search. So all those can be done efficiently in a data structure. And the example here I have given is a shelf. For example, let us take a shelf consists of a 3 row. In a first row we have a deep learning book, in second row we have a machine learning, in a third row it has a data structure book. So whatever books we need, we can access it efficiently in that particular row. This is what is about a data structure. And next is a classification of data structure. So what is classification of data structure? A data structure is divided into two types. One is linear and another one is a non-linear data structure. Next, linear data structure is divided into two. One is static and another one is dynamic. And again the static is divided into an array. And next one is dynamic data structure. A dynamic data structure consists of queue, stack and linked list. Next is a non-linear. Non-linear is divided into two types. One is tree and another one is graph. Array. What is an array? An array is nothing but a group of data elements that is kept in a consecutive memory region is known as an array. So we all know that the array starts with the index value from 0 to 1, 2, 3, it goes on till n, and the element which is inside an array we tell it as an array element. And next is a linked list. Linked list is nothing but it consists of a node which has one side will be the data and the other side will be the pointer that is nothing but a memory location of a next node. So that is nothing but a linked list. And next one will be a stack. Stack is a special kind of a linear data structure that uses a specific pattern of operation. So the first in last out or the last in first out are both valid orderings. It consists of push and pop operations. Next is a queue. This is also quite similar, whereas the queue will be performing the operations like in the order of first in first out. Here DQ and NQ process takes place. Next is a tree. Tree is nothing but the element of a tree, non-linear. It is hierarchical data structure, and the term root node, that is a source node, okay, will be referred to the highest node in the tree, and it consists of a parent and child node. Both will be there. Next is a graph. A graph is a non-linear data structure which comprises of vertices and edges. So vertices is nothing but the node, and edges is nothing but which connects the vertex from one to another. We tell it as an edge. Next, it can be defined formally as G is equal to V comma E. V is nothing but a set of vertices and E is nothing but a set of edges. Next is types of a graph. So types of a graph, we have directed, undirected, weighted, unweighted, cyclic, acyclic, connected, disconnected, all those are there. So directed graph is nothing but, let us consider a node. This is a 2 node, and here which connects from one node to another we tell it as an edge. So this we can tell it as an edge or either as a link. So this we tell it as a directed graph which specifies with an arrow. Suppose if it does not specifies with an arrow, we tell it as an indirect graph. And next is a weighted. Weighted is nothing but we allot some weight between one node to another node in the edges, that we tell it as a weighted graph. Unweighted, we does not allot any other cost or distance, some values are not assigned. Cyclic is nothing but let us consider here 3 nodes A, B and C. So from A to B we connect, and from B to C we have, then again from C to A we have. So this we tell it as a cyclic. A to B, B to C, and again from C to A it forms. So this we tell it as a cyclic, whereas acyclic it does not be like that. So A, B and C. So A to B, B to C, that's all. It will not connect from C to A. So this we tell it as a acyclic. And connected graph is nothing but when it connects from one node to another we tell it as a connected, and when it does not connect to one node to other node we tell it as a disconnected graph. Next is types of graph traversal. So types of graph traversal, we have two types. One is breadth first search and another one is a depth first search. First one is BFS. BFS is nothing but it is stands for a breadth first search, and it explores the data node level by level. First level will be the 0, that is a source node, and the next level will be the level 1, and then the second level will be the level 2. So level 0, level 1, level 2, it will be exploring the node by level by level. So that is called as a BFS, and here we use the concept called queue. Queue is nothing but first in first out. That is, here NQ and DQ process takes place. It is used to find the shortest path in an unweighted graph. Let's see the one example in BFS. So given the following graph, find its BFS traversal. So here we consider, we have here as 0, 1, 2, 3, 4. So we have how many nodes here? 0, 1, 2, 3, 4. We have 5 nodes here. How many edges? Edges is nothing but from 0 to 1, it consider 1, and then from 0 to 2, 2, 3, 4, 5 and 6. Okay, there are 6 edges and 5 nodes. Now the first one is we start with the source vertex, that is 0. Since BFS explores node by node, that is level by level, we are going to start with the vertex of 0. So 0, 1, 2, 3, 4, there it has visited RES and Q. What is visited? Visited is nothing but the node whichever is visited, there it shows us true. Okay, so when you see the next slide you will understand it. Then RES is nothing but a variable. Whatever the node has been visited, it is used to store in the RES, and Q is whatever node it explores, that it will be stored in a queue. Okay, now the first process is it starts with the vertex of 0. From 0 it reaches to, what are the, since it is level by level, it reaches to 1 and 2, both the nodes. So from 0, so the starting node will be 0, that will be first will be NQ in the queue. Okay, now it will be changed as a true, starting value is 0. Now the second step is visited RES Q. The node explores 1 and 2 there. So 0 explores there, 1 and 2. So what will happen is RES is equal to 0, that is node has been already visited, so that has been there. The node 0 which explores 1 and 2 will be there in the queue. So the first one, now again what happens is, comes to the next slide. From 0, 1 and 2 has been explored. Now again take the first one, that is 1. So from 1 the node explores to 3. So here the node 1 has been visited, it has been stored in the RES. Now Q. In Q what will be there? The node 2 and 3. What is the node next? Next node will be your 2. Okay, now node 2 explores what? Node 2 explores the 4. So now 4 has been there in the NQ. Then again go to the next, see whether 3 has any node. No, it does not have any adjacent node, so then it has been dequeued. Now only 4 is left over here. Check whether 4 has any neighbor. No, it does not have any neighbor node, so again you can dequeue it. Now the queue becomes empty. So what is the traversal? First it starts with the order of 0. The node explores 1 and 2. Then from 1 it explores to 3. From 2 it explores to 4. Then you are checking it whether it has any adjacent vertices. When it has no adjacent vertices, it has become, queue has become empty. So this is what? First in, first out. Next, let's go into the concept of DFS. DFS is nothing but depth first search. What is depth first search? Depth first search is nothing but it explores the node by path, whereas BFS explores the node by level. This explores by path. That is, it notes in BFS one node explores level by level, which means if it might be 2 node or 3 node, in that way it explores, whereas DFS it does not explore in that way. It explores only one node at a time. It goes into the very deeper path. So DFS explores path by path, going as deep as possible before backtracking. So it searches any adjacent node was there. If all the nodes has been visited, then it does the backtracking process. When you see the example, you will understand. Then it uses a stack. Then in DFS we use as a queue, whereas stack is nothing but it is a last in first out. Example, given the following graph, find its DFS traversal. So 0, 1, 2, 3, 4. We are going to take this example now. Let us start with visited RES. This is nothing but stack. So we start with the node of 0. Here 0 explores what are the node? 1. Okay. If it is BFS, it explores 1, 2 like that. But since it is a DFS, it explores only one node at a time. So 0 explores 1. So what is the node 0? So 0, first 0 is visited. That has been kept inside it has been pushed inside the stack. Next, the 0 explores the node 1. So 1 has been inside the stack. Now from 1 it reaches to the node 2. Yes. Then that has been push into the stack. From 2 again it goes to the node of 3. Adjacent node is 3. Only one node can be reached at a time. So the adjacent of 2 is 3 and 4. You can either reach 3 or you can reach 4. Now we are reaching the node of 3. So that has been pushed into the stack again. So 0 node has been visited, 1 node has been visited, 2 has been visited, 3 has been visited. Now one more node is there which is left over, that is 4. But now check whether 3 has any adjacent node. No. So it goes to the backtracking of 2. From 2 it has been reached to the node of 4. Now what happens is, since you are doing the backtracking process, pop process takes place, whereas 3 gets deleted. So now the back process goes to the backtracking takes place. From 2 you are reaching the node of 4. Now 4 has been reached. Now you have to check whether any adjacent node of 4 is present. No other node is present on the adjacent of 4. Now what happens? Backtracking process takes place from 4 to 2. Then from 2 to 1, is there an adjacent node? No. All nodes has been visited. Then again from 1 to 0. Okay. Then from 0 to any other node has been adjacent node? No. So everything has been, stack has become empty. This is what the concept of DFS. So first we start with the node 0. From 0 it reaches to 1. From 1 it reaches to 2. From 2 it has reached to 3. And again does the backtracking process and reaches to 4. Now the gate questions. Question number 1. The breadth first search BFS algorithm has been implemented using the queue data structure. Which one of the following is a possible order of visiting the nodes in the graph below? So here are the graph. So MNOPQR. Okay. Now they have given the 4 options. Let us check the option one by one and see which one is the correct one. Now first option is MNOPQR. So from the starting node is M. From M the node explores, since it is BFS, it explores the node by level. From M it explores to N, Q and R. Check whether it explores all these 3. All these 3 are explored. From M it explores to N. Yes, it is correct one. Then from M it explores to Q. Whether Q is present? No. Okay, let us check for R. Whether R is present? No. So it goes directly to O. So hence it is a wrong option. It should explore either, if it starts with a M, it should explore N, Q and R. Then only it should go to the next node. Next, let us go with the second option. So second option is the starting node given here is N, Q, M, P, O, R. Okay, the starting node we have took here is N. So what is the node of N? M should be there. So M should be there, O should be there, and Q should be there. Okay, so N explores Q, yes, it is correct. Then N explores M, yes, it is correct. Then N explores O, no, O is not present, it goes directly to the P. Hence, this one is also a wrong one. Okay, let us go for the next option, that is option number C. Now, the starting node of option C is Q. So, the starting node is Q. Q explores what are the node? It explores M, N, and O, P. These all nodes are explored. Let us check one by one. Q explores M, yes, it is a correct one. Then Q explores N, yes, it is a correct. Then Q explores R, no, Q does not explore. It is a disconnected graph where it has no any other link between Q and R. Hence, this option is also a wrong one. Next, let us go for the option D. So option D is starting node is P. Okay, P explores what are the node? Q and O. It explores all these two nodes. Okay, let us check now. Okay, P explores Q, that is the right one. P explores Q, yes. Then let us go for O. From O, it explores to N. Yes, it is a correct one. And O explores the node Q, P also, that is already visited. Then from N, now again we are going to go from the Q. Q explores the node of M and R. Okay, sorry, first M and then M explores the node of R. So hence the option D is a correct one. Next, let us consider the tree arc of BFS traversal. Form a source node W in an unweighted, connected, undirected graph. The tree T formed by the arc is a data structure for computing. Here are the four options listed. So the first option is the shortest path between every pair of vertices. The shortest path W to every vertex in the graph, the shortest path W to only those nodes that are leaves of T, and the longest path in the graph. So here let us consider a graph. So they are telling that it has a BFS traversal. So BFS node, it explores a node level by level. So that is what the concept. So let us take a graph here. So a graph explores the node level by level. Okay, so this is a source node. So from 0 to this level 1, calculate the distance, this is 1. Then from this node to this node is 1. So 1 plus 1, the node will be, answer will be 2. Again, this node to this node, the answer is 1. Then the distance between this node to this node is 1. So 1 plus 1 is 2. So it reaches the node by arc form. So that is what is given, tree arc. So what is the option? The shortest path between every pair of vertices. No, not only to the every pair of vertices alone. Then this is the wrong one. Next one is the shortest path W. W is nothing but the source node. So W to every vertex, yes, from W to every vertex in the graph. From there only we are calculating the distance all over the tree. This is the right option. Then W to only those needs, those are the leaves of tree. No, not only to the leaves of a tree. Next one is the longest path in the graph. The option is wrong. So the answer is B. Next question, consider the following sequence of node for the undirected graph given below. So there are the four options given here. The first one is a depth first search starts with the node. So they are given in the question itself, the node starts with the A. And let us see in the option, all the options are started with the node of A. And next, the nodes are listed in the order they visited first. First visited, which of the above are possible output? So let us see the option one by one now. So option A, so what are they telling? From A it reaches to B. Yes, from A it reaches the node to B. Yes, since it is DFS, it reaches only a one node at a time, as I said earlier. So let us see that from depth first search, it reaches with the starting node at A. The starting node is A here. So from A, it reaches to the node of B. Then from B, it reaches to the node of, what is the option? A we are saying, so it reaches to the node of E, okay. From E, it reaches to the node of F, this is also okay. From F, it reaches to the node of D. Not exactly, because it should reach either the adjacent node of C or the adjacent node of G, okay. Already the adjacent nodes have not yet reached, so it should not come back by doing the backtracking process and reach the node D. Hence, the option first one is wrong. Let us go for the second option now. So the second option is the starting node they have given already. We are going to start with the node of A. So from A, it reaches the node to B. Yes. So from A, it reaches to the node of B. Yes. From B, it reaches to the node of E. And from E, it reaches to the node of F. Yes. Then from F, it reaches to the node of C. Yes. Then from C, it reaches to the node of G. Yes. How come it reaches? Yes. Let us see whether the C has reached the adjacent. Yes, it has reached all the adjacent nodes. So hence, it does the backtracking process and then it reaches the node of G. And then from here it reaches the node of E. So this is what the process takes place. So hence this option is correct. Now let us check for the option C. Okay, so the option C starts with the node, as I said earlier. From A it starts and then it reaches, from A it goes to the node of D. Yes, so it goes to the node of D. Then from D it reaches to the node of G. Yes, it reaches to the node of G. Then from G it reaches to the node of E. Yes, it reaches to the node of E. Then from E it reaches to the node of B. Next step, from B it reaches to C, and from C it reaches to F. Hence this both options are correct. Okay, let us try for the fourth option also. So fourth option here is from A it reaches to the node of D. Okay, correct. From D it reaches to the node of B. Okay, from B it reaches to the node of C. From C it reaches to the node of G. No, not exactly. It should either reach the adjacent node of E or it should reach the adjacent node of F. So since these two nodes have not yet reached, it should not come directly to the node to reach the G. So hence this option also wrong. So the option is 2 and 3. So answer is option 2 and 3 only. Next, let us go to the next option, that is in a depth first traversal of a graph G with vertices K edges are marked as tree edges. The number of connected components G is. So here we have the number of connected components in G. So option A is K, option B is K plus 1, option C is N minus K minus 1, option D is N minus K, and answer is option D they are telling. Let us check how it is possible now. So let us check one by one. So here the option has given K plus 1, N minus K minus 1, N minus K. So here what is the question? Depth first traversal of a graph G with vertices K edges. Okay, let us take a graph. Okay. Now what they are telling, K is nothing but a edge. So here K is edge and N is nothing but, we are taking only one component, that is one tree now. So N is nothing but number of nodes. Let's calculate how many number of nodes are there. 1, 2, 3, 4, 5. So 5 nodes are there. What is K? K is nothing but the edges. 1, 2, 3, 4. So 4 edges are there. Now let us see The answer k value is 4. No, it is wrong. So B is k plus 1. 4 plus 1 is 5. No, it is wrong. Then n minus k minus 1. So 5 minus 4 is 1. 1 minus 1 is 0. That is also wrong. N minus k. That is value of n is 5 and k value is 4. So 5 minus 4 is 1. Yes, the answer is correct. Why the answer is correct? Because we have took the component as only 1. In the same way, let us check out for the component 2 also. Now, so let me take the component 2 distinct graphs, that is disconnected graph or there. So now we have the component value as 2. So how many? N is nothing but number of nodes and k is nothing but number of edges. So how many nodes are there? 1, 2, 3, 4, 5, 6. So 6 nodes are there. How many edges are there? 1, 2, 3, 4. Okay, let us check for the option now. The value of k is, actually the answer should be 2. So since we have taken the component as 2 component are there, so k value is 4. Obviously this is wrong. K plus 1, that is 4 plus 1 is 5. Answer is wrong. Then n minus k minus 1. Value of n is 6. 6 minus 4. 2. 2 minus 1 is 1. Answer is wrong. N minus k. So what is the value of n? N is nothing. 6 and k value is 4. So 6 minus 4 is 2. Hence this is the correct option. Thank you. We'll continue in the next session.